Now we're going over 4.1, exercise 4. Prove if A is an n by n upper triangular matrix with diagonal elements d1, d2 to the n, then the determinant of A would essentially just be the product of diagonal elements. So to prove this, I just use a 4x4 matrix, but the same concept could be applied with any size matrix. And so to solve this, I used the cofactor expansion of the first column. And so this works out because since there's only one entry that's non-zero, the rest would be zero and would just cancel out. So we're basically only worried about the first diagonal times the cofactor where you would remove the first row in the first column. And so essentially this would just be like a recursive relation where we just keep applying the same process over and over again. So right here we got the first diagonal times of the cofactor where you remove the first row in the first column, and essentially that cofactor would just be would just give you would just be like a new determinant where you would remove the first row in the first column, and we don't have to worry about any negative ones because as we'll see in a bit, since we keep removing that first row and that first column, then in the cofactor equation, -1 would be always be to the power of 2, which would just be 1. So we don't have to worry about any negative diagonals or any we don't have to worry about like any cofactors flipping the sign. It would just be 1. It would just be the same yeah, it won't change that. So as we can see here, so the new determinant where we would remove the first row in the first column would be this right here. And so as you can see, it's just applying the same process where the determinant would be the first entry multiplied by the determinant where you remove the first row in the first column. So which is right here. And so you just keep repeating that process, and then eventually you'll get down to the determinant where there would just be one single entry. And so in the book it states that for a determinant where there would just be one entry, then the determinant would just be that one entry. So which is seen here where with the last diagonal. And so with this process you could see that the determinant is essentially just multiplying each diagonal, which proves that the theorem is true.